Hi, welcome to my poster. My name is Rachel Elward and I'm talking about memory for spatial and non-spatial associations in developmental amnesia. Developmental amnesia is a memory impairment that develops following a hypoxic ischemic event in early life. Children with developmental amnesia have smaller hippocampi than typically developing children, and they have difficulties with spatial memory, with recall memory, and with episodic memory. According to the relational theory of memory, the hippocampus supports these processes by binding together all of the different items of an experience, so the different objects, the different elements that make up an event, and binds them into a complete whole. And similarly, the hippocampus might support spatial memory by relating together the relationships between different objects in a space, or the relationship between different objects and the boundaries of a space. However, the hippocampus does show quite a bit of functional heterogeneity across the subfields, and perhaps the pattern of deficits in developmental amnesia can be explained by understanding the different subfields and their contribution to episodic memory and recall and spatial memory. So in this task, we're going to look at spatial and non-spatial associations and link those to the different subfields of the hippocampus. We have 16 patients with DA, 10 of those are male and 21 controls, 9 are male, and we have a big age range, so that our participants go from age 8 up to age 36. This paradigm is previously being employed by other researchers. King et al. In 2004 was the first of those, but the study was adapted for children in this case because of our young sample. In the paradigm, participants walk around a virtual space by using the arrow keys on the keyboard. They follow a marked path where they'll meet 8 different individuals and get 8 different objects in 8 different places. And then a test, we have these 3 different tests I'll describe to you now. In the place association test, they're presented with a picture of one of the places they were previously in and asked which of 3 items they were given at that place. And all 3 items were presented in the previous phase, but only one of them was presented here in this area. They have to recognize the correct associate from the list. In the person association, they're presented with a person and asked which item did that person give to them. And in the object recognition test, they're just given 3 very similar looking items from a similar semantic category, from the same semantic category, and are asked which of these objects did you see. So this one doesn't require any associative memory, but the other 2 do. The results show that the DAs underperformed relative to controls on all of the tests. And we were particularly interested in whether or not there was a difference in the person and the place association, because they're both associative memory, but one is more spatial than the other. So here we did a 2x2 ANOVA between patients and controls, just comparing person and place associative memory tests, and we got a crossover interaction such that the controls found the place association easier than they found the person association, and the patients got the reverse pattern, but they found the person association easier than the place association. Turning to the brain data, the ICV corrected hippocampal volumes were segmented for each of our patients and controls. And of course the hippocampus and all of those subregions were smaller in the DAs than in the controls. Each of those is highly significant. But we're interested in these brain behavior correlations. And you can see from my very blue, I'll just zoom in, my very blue correlation matrix that all of the tests and all of the subregions were quite intercorrelated with each other. So it is true that the hippocampus predicts performance on all of the tests, and so does each of those subregions, except for the uncus, where we didn't see such striking results, but a similar pattern. But we're interested in whether or not there's a difference across these subregions, where some subfields correlate more strongly with some tasks than other tasks. So to answer this question, we ran some partial correlations, where we wanted to assess whether unique variance was accounted for by the volume of one region over the others. And in this case, we only found one significant correlation, and this is that the volume of the subicular complex was positively correlated with performance on the place test, so the spatial test, across all participants. We didn't find any significant partial correlations with the person test. What can we conclude from this? Well, we might conclude that spatial memory is a particular challenge for people with DA, and that the associations involving spatial images are just more difficult in this patient group. This is consistent with a huge amount of research suggesting the hippocampus is particularly important for spatial memory and for navigation. One interesting finding from this study is that object memory, so just simple recognition memory, was impaired in all of our DA patients. This is not consistent with data from previous studies, and even in a single case study involving patient John, in a very similar paradigm to this one previously, recognition memory was good. So we're not sure on the reason for that inconsistency here. In terms of the subregion analysis, total hippocampal volume and all of the subregions correlated with memory performance in all of the tests. It fell under significance for the UNCUS, but the trend was the same. But when we accounted for the volume of the other regions, only the subicular complex uniquely predicted performance on the spatial association test. This is consistent with the idea that the subicular complex is particularly important for spatial memory. So the pattern of deficits in DA may be explained by a pattern of damage to a heterogeneous set of subregions of the hippocampus. Thank you.